right. Hello, everyone. How are you guys doing today? Awesome. Sounds great. Excited to see many of you here. Curious, how many of you were here yesterday in the evening? All right, not that many. Cool. So yeah, very excited to talk to you about kind of a cross-chain, powering the cross-chain future, and what it means for the ecosystem in general. So very quickly, the 3 bullet points that I want to get across today is why do we want to build cross-chain, when do we want to build cross-chain, and how do we build cross-chain, and what are the important factors that you have to think about. So if you walk away today, just remember to write down 3 answers on your notepad, and you'll call today a success. All right, so on a very high level, the way the Web3 or blockchain ecosystem looks like is like this. It's really a collection of different countries that are all optimizing for their own stability, for their own growth. What does that mean? You have different blockchains that are optimizing for specific use cases. They have certain programming environments. They have certain distribution channels. And I just kind of slapped some names on the world map, but you can kind of make your own arrangements. So why is it important to connect all of these different countries together in a kind of a transportation environment? Well, think about what would happen if the world that we live in today didn't have connectivity between different countries, right? Didn't have roads, didn't have bridges, didn't have airplanes, and all of that combined. How would that actually look like? Well, it would be horrible, right? It would be kind of a back to the world where, if you had some idea or a paper that you wanted to communicate, you had to send a mail, and you send it across the ocean, and then you discover that somebody had your idea about 3 years ago, right? So your idea is not that new. So really kind of changed the way we live by having the connectivity across the different world. Same thing for the internet, right? It's kind of changed the way we interact. And today, all of these different countries are sort of distinct and disconnected. And what we know of as a multi-chain or cross-chain future is completely bizarre experiences, right? From a developer perspective, you have things that you have to think about. How do I deploy my application on multiple different blockchains or in multiple different countries? How do I optimize for user experience? How do I think about liquidity? Should I choose to build on blockchain X because it has liquidity of some stable coins, or should I build on another blockchain that actually has faster finality or better decentralization properties? So all those questions you have to answer as you're thinking about your application deployment. And as a result, the users are suffering, right? They have high gas costs that they have to pay for. They have to think about asset fragmentation. They have to think about multiple versions of assets, different wallets, and so on and so forth. So completely horrible user experience. And that actually has very practical economic output for the users. And I encourage you to kind of check out that article on interoperability and market segmentation and what are the financial impacts that users have as they hop into from one blockchain to another. So this is unfortunately what we're stuck with, and the kind of 2 classes of users that we really need to focus on when we think about why build cross-chain are developers and users. Developers at the end of the day just want to solve problems, right? I have a user wants to do X and Y. I need to give them an environment that has efficient gas fees, it has fast speed, it has great programming environments for me to build the application. So that's what developers want. And what do users want? Users need simplicity, right? At the end of the day, I want to be able to interact with any asset, any application with 1 click. Right, the user experience today of having to go from chain A to a chain B, bridge, swap wallets, get some gas fees, is completely bizarre. If we were in that experience in Web 2, we would not be very far along, trust me on that. So we have to solve that. So at the very high level, this is the cycle that we need to kind of think about. Developers are building platforms. Platforms solve specific needs of users. Users contributing back to the developer's growth or financially, whatever that output is. And today, that's partially broken. And we actually can't have this cycle unless we fix a lot of these issues and UX issues and fragmentation issues. OK, so now that we talked about why build cross-chain, let me talk about when to build cross-chain, right? I think there are many places in the life cycle of your application when that makes sense. I'll just point out 2 factors. One, you want to scale. Very simply, you have a product, you build it on one chain, it needs liquidity and it needs users, right? If you want to get more liquidity, if you want to get more users, you want to make sure you have cross-chain connectivity. And very simply, a lot of the kind of automated market makers, borrow and lending applications, and so on and so forth, they need to scale. And the second factor to think about is about differentiation, right? So if you're building a cross-chain native application that you can actually differentiate on the UX, you can differentiate on the kind of trading pairs you can create, you can differentiate on the functionality of your application compared to 1,000 other versions of automated market makers that are all doing similar things, and you have to think about what is my unique differentiator in that world. So those are kind of just two things to think about. All right. So moving on, let me tell you a little bit about kind of Axeler and what is the stack that we're building on the very high level. It's a stack that allows you to build cross-chain native applications. It consists of 3 different layers. There is a service layer that serves in the middle. Underneath it, there is a network layer. The network layer very simply allows you to connect different blockchains in a proof-of-stake decentralized network and move information from one of these networks to another, right? So you can move information from Ethereum to Avalanche to Polygon to Moonbeam to Cosmos chains and so on and so forth. On top of the network, there is a service layer. The service layer allows you to perform very sophisticated types of kind of experiences or enable these types of experience for your users. So as an example, you want to allow your users to execute a transaction with one click on the source chain. And even if this transaction actually has to touch various applications on other chains, you don't want them to have to pay gas. Right? Because paying gas is very painful. They have to have the native token. They have to find it, convert it. So it ends up in many, many clicks that they have to do along the way. So these services allow you to code an application in a way that, as a user, you can pay the gas on the source chain, and this transaction can propagate to other different chains, execute various functionalities, and return the result back to the user. And on top of it is an API layer. API layer is something that obfuscates all of this complexity and services in a very simple to use API. And so if you're familiar with things like Stripe or Twilio, those are APIs that are exposed to the developers to either send messages or perform kind of across institutional transactions. This API layer is something that can allow you to do kind of across blockchain transactions. So very simple, you just specify where you want to go and what it is you want to communicate. All right, so at the network layer itself, there are various components, and I don't want to go too much into it. There's a consensus, there's like finality gadgets, kind of a crypto, and so on and so forth. And so I encourage you to take a look at the white paper and read a little bit if you're interested in the technical aspects of this. There is a Axeler scanner. You can take a look at it. So axelerscan.io. It gives you a high-level overview of the Axeler network itself, right? So as I mentioned previously, Axeler network is a sort of a blockchain to connect blockchains. So it has its own validator set. It has its own functionality. It just that functionality is kind of a customized for cross-chain validation. So you can see how the validators are performing. You can see what are the connections on the network. You can see packet flow, who is sending packet to whom. So very sophisticated kind of a tool. It also has its own API, and I encourage you to check it out. As the network itself, it can support various types of functionalities. The first one, I think everybody is familiar with, things like asset transfers, right? I have an asset, I want to send it to a specific user or specific destination chain. There are multiple methods on the network layer to do that. You can get a deposit address, or you can communicate from one smart contract to another. For the deposit address, something really powerful because that allows you to communicate cross-chain directly from a centralized exchanges or directly from dumb wallets. Right, so a lot of the time when you go cross-chain, you actually had to sign a transaction with things like MetaMask. You actually don't need to do that now. You can generate an address, and you can withdraw funds there, things like USDC, directly to this address. And then because the network itself aware of what to do with this transaction, it will route it and deliver it to the destination chain, and you don't have to think about it. Awesome. And the last thing that I want to talk about variability today is kind of this new programming model that we're entering in the blockchain ecosystem that supports arbitrary message passing, or what I call as Turing-complete cross-chain communication. Right? So traditionally, when we think about cross-chain and token transfers, we mostly focus on the functionality of sending a token from A to B. Right? Which is great. You know, Bitcoin used to do the same things. You can send a Bitcoin from a user A to user B, and then we had things like, you know, Ethereum, right, that allowed us to really develop kind of a Turing-complete applications that have all kinds of rich functionality into it, and really minimize the complexity for the developers and users to interact with all of these platforms. And so the same thing, things like Turing-complete cross-chain communication allow you to send arbitrary messages or contract calls from one application on one blockchain to another application on another blockchain, right? And so all the things that you had to write out manually for your users to do, like take a token, go to this bridge, do the swap, get a native gas fee, pay for your transaction, you know, go to another bridge, return transactions to some other blockchain. All of those steps you can now automate in a sequence of instructions, and that instruction can be passed as a message to execute all of the user intents with one click, with one transaction. All right? So you can program a lot more at the network by having this ability to send arbitrary messages from one blockchain to another and compose your contracts. And so the key insight is that traditionally, the way we've been thinking about building a cross-chain native application is by having users move their assets to the application. Right? And now you can really build a new type of experience where you can move part of your application logic to where the assets are, where there is a deepest liquidity of the asset, perform some type of computation over it, get the result, and then communicate it back to the user potentially on a different chain. Right? So it's kind of a really a new paradigm shift where we now have those two options, either to move assets to where the compute is, or you can move compute to where the assets are. And so the next generation of applications, I claim, will have more and more use cases where the compute is actually moved to where the asset is, certain computation takes place, and then you return the result. So really powerful. This is high level, like incredibly simplistic view of how things work. You have source contract, destination contracts. You send messages between them through the gateways. Gateways, you can think of them as routers, right? So everybody has a router at home. It's responsible for sending messages from A to B. And same thing in this case, we have the notion of gateways, which are software analogous of routers, and they can sort of know where the packet needs to go from A to B. All right. And so the final message that I want to just leave you out there is to, as you're thinking about building your Web3 application, is really think about how do you simplify it and how to make it more accessible for retail users. Okay? If you're talking about, you know, having enterprises, traditional retail, use your application, the UX, the experience, the fragmentation and liquidity problems, just not going to scale. All right, they're not. You know, in Web 2, the way the applications are built, they are hosted on a specific environment that allows users from anywhere, from any network, from anywhere they are in the world, access those applications. Right? And so to do that, you really have to think about how do you build in this developer paradigm, how do you build a kind of a cross-chain native application that has the same type of functionality where your application can be accessed from any wallet, from any chain, by the users directly with very simple UX. So think about how to do this, and I think this is the key to continue to build in this space. So on that, I'll leave you with a couple of QR codes on the network on Discord, and happy to chat more after the presentation. So thank you very much.